All right, folks, this is Larry Mussolino. I'm recording a short video here for the Module 1 discussion in Math 112. A few students were asking me for a little bit of help on graphing these functions. So let's take a look here. So first it says, review the Desmos user guide. Desmos is a free online graphing tool. And then it says use Desmos to graph the assigned three functions. And I'll scroll down in a minute and show you how you'll know the assigned three functions. And then says using the graph of the function, what is the domain, the range? What are the equations of any horizontal and vertical asymptotes? Okay, so let's take a look at this and let me do a few typical examples from this. Let me scroll down to the bottom. Hold on a second here. Let me scroll down to the bottom of the screen and I'll kind of show you the instructions. So here's something I posted. It says each student is assigned a student number. And if you click on this Excel file right here, it'll show you your student number. Then you go to this link. I'm going to click on it and it'll show you all of the functions that you're going to graph. Okay, so let me come here. This is what you'll come to when you click on that link for Desmos. And I'm going to pick an example at random. Let me come to student 16, and I'm going to click, and I'm noticing there's three functions, A, B, and C. So let me start with function A. And I want to make this graph visible on this XY coordinate here. And so in Desmos, if you come over here to the circle and click on it, I'm going to click on it right here, it activates the graph. If I click again, it makes the graph invisible. So let me click on this first one and we can get started on this. I'm going to make this a little smaller. So over here on the right, there's these zoom in, zoom out buttons. I'm going to zoom out a little bit. And that looks a little better. All right, so here are the questions they're asking us. What is the domain? What is the range? And then what are the equations for the vertical and horizontal asymptotes? All right, let's talk about each one of these. How about domain? Well, domain is really asking you what are the x values that the function can take on? And you might say, well, can't x be any value at all? No, not necessarily. Because there's a couple of constraints on the values x can take on. First of all, you can't let x take on a value that would cause division by zero. Division by zero is not allowed. So I can't let x take on a value that would cause this denominator here to equal zero. Another condition you have to be on the lookout for is the square root of x. Well, you can't take the square root of a negative number. That doesn't get you a real value. So I could not let x take on a value that would result in the square root of a negative number. Now, there's no examples here with square roots. So I don't have to worry about that. But I do have to worry about division by zero. Now, when you're looking at a graph, the domain is really the horizontal span of the graph. What that means is you want to look at the graph and ask yourself, how far does this graph extend from left to right? And are there any breaks or gaps for the x values? So, and by the way, of course, you remember the horizontal axis here is called the x-axis, and the vertical axis is called the y-axis, right? So for this example, let me look at the horizontal span. I'm asking myself, how far does this graph extend from left to right? Well, I'm noticing it goes all the way to the left. We call that negative infinity. It goes all the way to the right. We call that positive infinity. But there is a break right here. Let me try to draw this vertical line at, you might notice here, this is at x equal negative 3. So there is a vertical line here. And actually, I could draw it in Desmos. Any vertical line, so let me keep drawing this here, this is going to be a vertical asymptote. Well, this red line I'm drawing is the line x equals negative 3. So anytime you want to write the equation of a vertical line, any vertical line is going to look like x equals a number. How about a horizontal line? Well, the equation of a horizontal line is always y equals a number. All right, and there's one other vertical asymptote here. There's one other vertical line that the graph does not take on any values for, and it looks like it's right here at x equals 7. So I'm going to project this up. If you can kind of see it, and you can scroll up and down in this graph to kind of see a little better that these are vertical asymptotes. All right, so I'm ready to answer the domain question. It looks like this graph goes from negative infinity to negative 3, but it doesn't include negative 3 itself. So this interval we write as negative infinity, negative 3 in parentheses like this. This is called interval notation. And whenever you write interval notation, you always write the left endpoint first, comma, the right side, the right end. All right, let me go to the middle here. X can take on any value here between negative 3 and 7, but X can't take on negative 3 and 7 itself. So I have to exclude that. So I'm going to write this as negative 3 comma 7. And finally, this portion over here would be going from 7 to positive. So to write the domain, if I want to write it in interval notation, I would write it as negative infinity, negative 3. And then usually we put a union symbol here. Union means we really want to join these 3 separate intervals together to form the domain. Union negative 3, 7, and then union 7, comma. So that would be the domain. Again, I'm trying to specify the horizontal span of the graph. And the graph is really going all the way to the left, all the way to the right, but it has these, we call them vertical asymptotes. So we know the answer to the vertical asymptote question. It's x equals negative 3. That's one vertical asymptote, x equals 7. A vertical asymptote is a vertical line that the graph does not cross. The line gets closer and closer to, if you look at this green portion of the graph here, it's getting closer and closer to this vertical line, x equal negative 3, but it's never going to touch it. All right, so that's the domain. By the way, another way you can figure out the domain algebraically, so to find the domain for these fractions, you can set the denominator equal to 0. That would tell me what values to exclude from the domain, right? Because these are going to tell me the x values that cause division by 0, which is not allowed. So to find the domain, what I could do is set the denominator equal to 0. I don't have to do this because I can just read it from the graph, but this is just a little bit of an extra confirmation. So I'm going to take this denominator and set it equal to 0. Well, this is called a quadratic equation when it has an x squared in it. One way to solve a quadratic equation is to do something called factoring. You might remember factoring from algebra. And I put an x and an x in front here. And now I'm looking for two numbers that have to multiply to this constant negative 21. So I'm looking for two numbers. I'm going to say here we need two numbers that have to multiply to negative 21. But then they have to add to this middle term negative 4. So they also have to add to negative 4. So I need to figure out, this is a little bit of a logic puzzle. Well, if you think about it, negative 7 and positive 3 should do it. Because negative 7 times 3, it multiplies to negative 21. But negative 7 plus 3 adds to negative 4. So those are the two numbers to plug in here. All right, and then to solve this equation, you can set each parenthesis separately equal to 0. So I'm going to take this x minus 7, set that equal to 0. And then separately, I'm going to take this x plus 3, set that equal to 0. Now I'm going to add 7 to both sides here. So that's going to get me x equals 7. And I'm going to subtract 3 from both sides of this equation. That's going to get me x equal negative 3. So these are the two numbers that cause division by 0, x equals 7, x equals negative 3. And of course, those are the vertical asymptotes we came up with by looking at them. All right, that's the domain. Let's go ahead and look at the range. Okay, I guess I'll clear this to make it a little cleaner. Well, the range are the y values that the graph takes on. What that means is you're looking at the vertical span of the graph. So that means you want to look from the bottom to the top and ask yourself, how far does the graph extend from bottom to top? All right, well, I could see there really is this gap, like right about here, where the graph doesn't exist vertically. So I want to be able to figure out this, this interval here. Well, again, I'm going to use the graph for this. And so let me do this. Let me try to find the tallest part of this curve. I'm going to estimate it to be right about there. So it looks like it's 0.083, right? That's the y value. Again, I'm just estimating this from the graph. So this portion of the graph is going from negative infinity to 0.083. All right, let me look at this part of the graph. Now I'm noticing, I think I should try to focus on this side of the graph here. Let me see if I can click on some values here just at random. And I want to see, so it looks like these y values are about 2.87. Let me come over to this side. I want to look at these y values. These y values are above 3. So I'm going to go to the left a little bit here, and I'm going to just pick a y value. It looks like 2.926. So I'm going to use any of these values here as my estimate, 2.93, I guess. I'm going to round up and say 2.93. This is not an exact value, but remember that this question said estimate the domain and range by using the graph. So again, I think I picked, what did I say here? I forgot what I just said. 2.9, what did we say here? I'm just going to scroll over a little bit. 2.93, let's use, okay? It doesn't have to be exact, so 2.93. So this is going from 2.93 up to infinity. All right, so let me write each one of these intervals separately. So for the range, I'm going to put negative infinity to 0.083. That's this bottom part of the curve. Union 2.93 comma infinity. Okay, remember when you write these intervals, you always have to put the smaller number first and the larger number second. That's always the way these intervals are set up. Okay, we're going to see later that there is a way to get a more exact estimate for this horizontal asymptote. Okay. All right, well, that was the other question then. What is the horizontal asymptote? Well, remember we came up with this estimate of 2.93 as this lower value here. Now, a horizontal asymptote is a horizontal line that the graph gets closer and closer to. So, and a horizontal line is always the equation y equals. So I'm just going to use y equals 2.93. Okay. All right. So let me go to the next graph. Again, these are not exact values. We're approximating these from the graph. All right, let me go to function b, and we'll take a look at this one. All right, so this is kind of a weird looking graph. Let's figure out the domain and range to begin with. So the domain is the horizontal span of the graph. So let me look horizontally here. And I could see the graph is going all the way to the left here. You see it's going all the way left. And it's always also going all the way to the right. But there is this one vertical line. Looks like it's going to be here at -3. There is this one vertical line that the graph is getting closer and closer to, but it's not touching. So we can write the vertical asymptote right away. X equals -3. You can also see that by setting this denominator equal to 0. If I said x plus 3 equal to 0, I'll subtract 3 from both sides. I get x equal -3. So, yep, that is the vertical asymptote. Well, what that tells me then is this domain is really going to extend from -infinity to -3. So this interval is -infinity, -3. And then on this side, it's going from -3, infinity. Now, when you put a parenthesis here on interval notation, it means that -3 itself is not included. So this is saying that the interval here is all real numbers except -3. This is a way to say -3 is omitted from the domain. So to write this in the fancy interval notation, -infinity, -3 union, -3, infinity. All right, how about the range? Well, the range is the vertical span. And I could see there's this one vertical span for the graph, and then here is another vertical span for the graph. And this is a gap, here is a gap where the graph doesn't exist vertically. All right, so let me look at this. I'll call this the bottom portion. And I'll call this the top portion of the graph. Let's look at the bottom portion. Well, I know this is going from -infinity up to this maximum height right here. So let me figure out that point. So let me click my mouse there, and it looks like that y value is -2. And let me click on this one while I'm here. It looks like that y value is +2. So what I can write then is this is going to -2, and this is +2. Remember, we're focusing on the y values here. So here is our range in interval notation. The bottom part is going to be -infinity, -2. Now for this -2, I'm noticing this point is actually on the graph. So that is a y value that's included on the graph. So when it's included, you put a square bracket like this on the interval notation. And then for the top portion, it's going from 2 to infinity. And again, I'm using the square bracket. That indicates that the value 2 itself is included as part of the range. Okay? Now, whenever you write -infinity or +infinity, you always show a parentheses with -infinity or +infinity for interval notation. Okay, so that's the range. Remember, one more reminder, whenever you write an interval like this, you always put the smaller number first and the larger number second with a comma in between. The last question was horizontal asymptotes. Horizontal asymptote is a line, a horizontal line, that the graph is getting closer and closer to. Well, there is no horizontal asymptote here, right? There's no horizontal line that this graph is getting closer and closer to. I am noticing something weird, though. I am noticing there's a slanted line here. We call this a slant asymptote. Here is a slanted line the graph is getting closer and closer to. So we call this a slant asymptote. But this question didn't ask us to identify that, so we don't have to worry about that. All right, let's do one last example down here at the bottom. And here is a graph. It seems to cover the entire x-axis, right? So there's no gaps horizontally for this graph. It's going all the way from the left all the way to the right with no gaps. It looks like there's no vertical asymptotes for this one. And the domain is going from -infinity to +infinity. So the domain, I'm just going to write as -infinity, +infinity. Remember, anytime you write infinities, you always put parentheses on the interval notation. All right, what about the range? Well, the range is the span of the y values. And so again, I'm just going to estimate it from the graph. Talk more about how to come up with better estimates later. But let's take a look at how far this graph is extending vertically. Well, it looks like it's going up to this kind of maximum point here. So I'm going to say that's 4.155. So this height is 4.155. That's the maximum. And let me try to figure out how far does this graph go down. And I'm going to click on some of these. So this is it looks like maybe there's a lowest value right there. Look at it, 1.845. I think that's the smallest y value I'm going to be able to come up with. Let me click over on this side. Yeah, this side looks like the y values are above 2. And so let me come over here, and I'm going to say 1.845 is this bottom value here. So this is 1.845. And that's really the range, because that's the vertical span. This vertical span is kind of a tight span. So the range, I'm going to write as 1.845, 4.15. And again, I'm putting square brackets on this because this point 1.845 actually falls on the graph. I can see it right here. And this 4.155 also is a point on the graph. I can see it right here. All right, what about horizontal asymptotes? Well, horizontal asymptotes are a line, horizontal line that the graph is getting closer and closer to. Well, I'm going to come over to this right-hand side and look, because it looks like this side of the graph is floating down, getting closer and closer. This side of the graph looks like it's kind of doing something weird. This side of the graph seems like it's doing something like it's going down, and then it's coming to this point 1.845 on the negative 3.732. And when it hits that point, then it's kind of going back up like this. So on this left side, it doesn't look like there's a horizontal asymptote here. But on the right side, this does look like a horizontal asymptote, because this line seems to be approaching this horizontal line. So let me see if I can estimate that. I'm just going to go to get rid of some stuff. I'm just going to click my mouse here and see what happens. Looks like it's 2.08. I'm just dragging my mouse here. It's 2.01. And so it looks like it's getting closer and closer to 2. So I'm going to say the horizontal asymptote is a horizontal line approaching 2. So the horizontal asymptote, I'm going to say, is y equal 2. Remember, anytime you want to write a horizontal line, you write it as y equals a value. Okay, so the idea for this discussion board is use the graphs here in Desmos to come up with estimates for these 4 questions. The 4 questions are, what's the domain? That's the horizontal span of the graph. What's the range? That's the vertical span. What are any vertical asymptotes? Those are vertical lines that the graph gets closer and closer to but doesn't reach. And what are horizontal asymptotes? That's a horizontal line that the graph gets closer and closer to. Anytime you want to write a vertical asymptote, the equation is going to be x equals some number. Anytime you want to write a horizontal asymptote, the equation is going to be y equals some number. All right, hope this is helpful as you're working in the Module 1 discussion.